recursive algorithms. Yeah. The topic, yeah, I think most of you have some experience about recursive algorithms. But here, for this module, we will learn in some systematic way. Yeah. So because it is very important. Yeah. So we need to really understand recursive algorithms. Part A, Introduction to Recursive Algorithms. Yeah. 8.1, First View of Recursive Algorithms. All right, yeah. So first, let's consider that recursive thinking. Yeah, the thinking way is quite different. Yeah. Recursive, non-recursive, let us compare these two different thinking ways. Yeah. We are used to non-recursive thinking. Yeah. But here, to solve a large class of computing problems, recursive thinking is a very useful method. Yeah. All right, so let's see the question, why recursive thinking is important in problem solving. All right, yeah, so we're used to straightforward, non-recursive thinking in problem solving. Yeah, because we feel comfortable, right? Yeah, so we can see, what we are doing step by step in a non-recursive way. Yeah, but for the recursive thinking, you need to make some assumption. Yeah, you need to assume that some special case, some you make your problems, yeah. So make your problem smaller, make your problem in smaller problem size. Yeah, here. So here we are targeting the problem size. Yeah. And we know the smaller the size in general. Yeah, so here in general, the smaller the size, the easier the problem. Yeah, so we have this basic fact. Yeah. So with that, yeah, that means when we solve problem, we should start from small problem sizes. Yeah. So that's easy to understand. Yeah. All right. So then change, make, yeah, let's say make the size larger. All right. Yeah. So that's the quite natural way. Yeah. All right. But, so here, but the question, we cannot go through all problem sizes, right? Nobody can go through all problem sizes, all right? Yeah. All right. So from implementation point of view, nobody can go through all the problem sizes. Yeah. But our thinking should cover all problem sizes. Think about this logic. Implementation point of view, nobody can go through all problem sizes, but our thinking should cover all problem sizes. All right? Yeah. So here you can see there is a gap. There is a, significant gap between these two things. Implementation point of view, thinking point of view. A big gap. Yeah. How to bridge the gap? Recursion. Recursion helps us bridge the gap. Recursion. Right? Recursive thinking, recursion. Because for recursion, we can make reasonable assumption. Okay? Although we cannot go through all problem sizes, but we can make a reasonable assumption to cover some of the problem sizes. Then by recursion, we can cover all the problem sizes. That's the idea. Okay, assumption. Yeah. So here, yeah. For conclusion, assumption plus assumption is reasonable, but it does not come from nowhere. All right, it comes from certain states of the problem. Yeah, we have those states. That's what we say, initial states. Okay, initial states. Yeah, we have that. Okay, yeah. So assumption plus recursion. Okay, yeah. Then for all sizes. Yeah. So in this way, we bridge the gap. We can cover all the problem sizes. Yeah. So that is the basic idea of recursive thinking. Yeah. So with that, some problems can be solved in both ways, non-recursively and recursively. Yeah. Because sometimes people prefer using the non-recursive way. Sometimes people prefer recursive way for the same computing problem. Now, we will have that kind of situation. Now, each way, there is some advantage and disadvantage. Okay? Yeah. All right. And we will discuss, the relative important points. Yeah. All right. Now, the one of the most important advantage for the recursion, power of recursion. So this is big advantage. Yeah, the power. Yeah, we like the power. It's very powerful. Yeah, so this point is big advantage for the recursion. Okay. All right. Some relatively hard problems can only, parenthesis only. Yeah, yeah, because, you know, in our textbook, it said it does not have this, all right? Be solved by recursion, because the author of our textbook, the author feels any computing problem, if it can be solved recursively, then there must be a non-recursive version for it. Yeah, but in the real world, we will have many times we couldn't find non-recursive solution. Yeah. In today's class, we will have a question, simple question. And it is extremely hard to find a non-recursive solution. Okay, yeah. So for that reason, I put this parenthesis only. Yeah. Okay. All right. Yeah. So then we may compare non-recursive way, we call it iterative way. Yeah. Sometimes we prefer this way. Yeah. Iterative way. Yeah. Because there is some advantage. This advantage, we like to have it. If it's possible, we like to have it. Yeah. So what's that? Yeah. It is less resource. Less resource. We like this part. If the implementation is not too hard, then we like to use the iterative way, so we can use less resource. Right? Yeah. Why? Yeah. Later I will have chance to explain that. Yeah. Recursive way, yeah, it is powerful. Yeah, this one. That's the, you know, most important reason we like to take this recursive solution. So powerful. Yeah. But the power is not free. You have to pay the cost. The power has some cost, relatively high cost to pay. So what is the cost? This is the cost. Consume more resource. Yeah. And we need to pay for that relatively high cost. Yeah. But implementation is easier. Yeah. Implementation for the recursion. Yeah, that's the advantage part, easier implementation. We like this advantage. Yeah. Here you can see two advantages. One, powerful, another, easier implementation. Yeah. All right. But the cost, yeah, you may ask why the cost is high, right? Yeah. Why the cost is so high? Yeah. You need to go to the internal implementation for the recursion. Yeah. Inside computer, you know, high-level programming languages, we know the recent high-level programming languages all support recursion. They need to manage the resource for the recursion in a special way. Yeah. Here, let me explain a little bit. Yeah. Inside the main memory, so suppose this box is, you know, in computer main memory. Yeah. The resource mainly there, main memory hard drive, right? Yeah, we treat as computing resources. Yeah. Here in main memory, how to implement recursion. Recursion. Implementation. All right, yeah. So we need to use a special data structure called a stack. Okay, yeah. in CS3250, you learn the data structure, stack structure, first in, last out, right? So it's processing order, first in, last out. Yeah. All right. So when you, because in recursion, you need to push your steps, in the stack one by one. Think about that, one by one. Yeah, push into the stack. Yeah. The first thing you push in, it's at the bottom of the stack. Right? So that's the recursion levels. Yeah. Think about recursion levels. Yeah. So you call the recursive function, but the value is not available, then you push it into the stack. And this unknown value relies on another recursive function call, but that value is still not available. So you can only push into the stack another time, and so on. Yeah. In this way, you can see the stack, could be very deep. The stack could be very deep. Okay. And a deep stack consumes a lot of resource. Think about that. Deep stack consumes a lot of resource. If your algorithm uses too much memory resource, it could be very slow. Okay? It could be very slow. Yeah. And there is a possibility. Remember, some of you may have the experience to have the runtime errors called stack overflow. Yeah, think about that. Yeah. The stack, you run out of the memory resource. The memory resource available cannot handle that deep stack you need for your algorithm. That could happen. In that situation, you will have a stack overflow problem. Okay, so your program terminates due to that reason. Run out of resource, that reason. So that's the problem we don't like to have, right? Yeah. So that's the disadvantage part. When you use the recursion, that could be the disadvantage part. Yeah. Even with that disadvantage, yeah, because its power is so big, its advantage is so big, and we like to have this recursion tool in our toolbox. Okay, it's a powerful tool in our problem-solving toolbox. All right, yeah. So that's the,